chance of wood burning. The reason gasification is important is because you burn a lot cleaner, which means you burn a lot more efficiently, you burn less wood. So this is one way to gasify the wood, is the way this boiler does it. This is a batch burn. In other words, we burn full tilt boogie until the wood is gone. It puts all the energy that was in the wood into storage in the tank. Each tank here holds about 1,800 gallons of water. Who can tell me how much a gallon of water weighs?
8 pounds.
8.33 pounds. Who can tell me the definition of a BTU? British thermal unit.
BTU.
That's the amount of energy it takes to raise 1 pound of water 1 degree.
I see that.
Or if you're given energy to a building, it's the amount of energy given from 1 pound of water dropping 1 degree. So it's very easy to calculate how much storage is in this tank by multiplying the gallonage by weight by temperature. That's available for you. And again, I'll go through that a little bit more if you want to stay later. I won't take all your time right now to do that. So this type of boiler does a batch burn. It all gets burned up, all the energy goes in storage, and is being used to circulate to and from the buildings at the same time. But the key is storage. I want you to think of that as charging a battery. Think of it as charging batteries so you can maintain a charge throughout the day or until, at least till the next burn. If it were me running them, I would target a 180. I'd want to get every time you load it, try to get up to 180. Because then you can go spend time doing whatever you want to do the rest of the day. Come back and, depending on the temperature outside, come back in 5-6 hours and check and see what's happening.
Temperature at 180.
Get the tank temperature up to 180 is what I would do. We don't want to get much above that. When we get up and look at the inside of the tank, I'll show you, it's an open system. In other words, it's not pressurized. There's a layer of air from the water level to the top of the tank, steam. And actually, this is an overflow pipe. This actually goes through the end of the tank, through the water, and up into a manway cover that we'll see up there. If the water expands too much, it'll overflow here and come out on your feet if this bucket's not here. We don't want to do that. We don't want to steam too much because the steam will condense in this tube and run out here too. In other words, we want to keep the water in the tank. So it's best to limit it to around 180, 185. The building, the clinic is not hooked up yet. This building at these temperatures needs about 140 degree water to be doing the whole load. Probably even closer to 150. That means we want to charge that battery, get up above the 150 so that we can walk away for a while and let the battery become discharged by dropping down in temperature and still heating the building. Or if it were me, I wouldn't want to stand here just putting the wood continuously in these things all day, keeping it at 150. I want to get up above that so I can take a break and do something else. Okay, so wood gasification, the idea of thermal storage. Something I wanted to point out was every bit of paperwork for every component here is right here. And the most important thing that I would get familiar with if I were you is the manual. In fact, I'm going to take turns just holding one of these. I'm going to ask you questions out of the manual. Or no, I'll put it another way. You correct me if you find something I'm telling you that's wrong. Anybody want to take one? So whenever you have a question about GARN specific stuff, you're going to find it in there. That's what you're going to find in there. I'm going to try to get you up to speed quick, but always be quick to refer to that. Okay, let's look at the control. There's multiple sensors attached to this control. We have a tank sensor, which is immersed. It's kind of captured on the manway. We'll get up there and look one at a time so you can see what I'm actually talking about. There's a stem dropped down into the water that has a temperature sensor on it. That's tank temperature. There's also a float switch on it. So nothing's going to happen here if there's not enough water in the tank. You won't be able to burn. You won't have electric backup if there's not enough water in the tank. This whole water alarm will light if that float level sensor is not satisfied. Okay? There's quite a bit of buffer there. You'd have to lose about 100 gallons of water right now to have a low water condition. Next on the menu is flue temperature. Well, just so you understand, before I go through, let me explain the flue a little bit first. After we're doing the one that's not burning. But if you see inside this tank, well, you can see the firebox here, right? About 2.5 feet in diameter, about 41 inches long. The tank is actually right about here. So this whole collar is outside the confines of the tank. This is an air collar. If there was a hole right here, we'd look all the way to a hood that's coming in the side of the building in there. That's our combustion air. We're drawing in combustion air through that hood. There's what's called a primary air nozzle right here. Just directing air, all our air goes sideways right here. There's a secondary air nozzle here that's directing a lot of air over the top of the hood, and then mixing with the gases as it gets to the back of the fuel load.
It's being blown in.
It's being sucked in.
I mean, sucked in.
Yeah. So if we, let me just continue starting at this point. And next down to about an 8-inch diameter, they call it a reaction chamber. It's a type of refractory that can get very hot, and so it will not quell the combustion of the gases as they're going through there. If it was just steel up against relatively cool water, in other words, no more than 180-degree water, the gasification process would stop there. It would condense on the side of that steel, and you have a dirty burner, you have high maintenance. But that reaction chamber is very important to both the efficiency and how much maintenance you got to do on this unit. So I'm saying if it gets damaged, replace it. Super easy to do. Next down to, I believe it's 5-inch well casing. It goes all the way to, this is all inside the tank now, immersed in the water, all the way to the back of the tank, straight down. I'm going to actually show you what this is. I'm not sure. So all the way to the back of the tank, down, all the way to the front. Feel right here. This is the run of a T. The branch of the T is facing this way. So the flue gases are going to the back, down, towards the front, transfers to this flue way, all the way to the back again, up on an angle, and this is the fan that sucks it all the way to that point. So the air is being sucked into these ports by this fan. The last path, the 5th path, is the only one that's pressure. The fan is pushing this way. This is where our flue temperature sensor is. So back to the control, that's the temperature that this thermocouple is seeing right now. It's 319. Next one is outdoor air temperature. This is really just, unless you're using electricity to heat, which I would not recommend, the controller uses the outdoor air temperature to plot a curve. So like on let's say a 20 above day, it's only going to make 140-degree water, but on a 20 below day, it's going to make 180-degree water. So the colder the temperature, the higher temperature the electricity would heat it to. I would not recommend using electricity. So that's the only reason the outdoor sensor is there. The next sensor is water supply. When you walk to the back of the tank, you'll see a pipe near the top of the tank that is the supply pipe. There's a sensor strapped to that. And there's a sensor strapped to the return, which is at the bottom of the tank. And then back to the tank again. So the control, I'm going to open this one up a little bit. The way these are set up, the decision was made to have electric backup. So if you run out of wood, nobody's available to put wood in it, some disaster happens, nobody's around, we're not going to freeze up. And the way it's set right now is it'll make the water temperature will drop to 45 degrees, heat with electricity until it's at 50, stop. Drop to 45 degrees, heat again, up to 50 and stop. If you ever want to, again, I wouldn't recommend heat with electricity. If you ever wanted to do this switch right here, this is all well described in the manual, SW1 switch. Has 4 different settings on it. Right now it's on 1. If you look at this label right here, tell me what it's going to do on position 1. 45 degrees. 0, tell me what it's going to do on 0. You set it on 0. Okay. Some with you have my glasses?
No. 0?
Yeah, right this label right here.
Didn't know there'd be this kind of test.
So on 0, it's disabled. You're not going to have any protection from freezing. So only turn it. Well, I wouldn't turn it there. I guess is what I'm saying.
Why is it an option at all?
Pardon me?
Why is it an option at all, 0?
Some don't even have this feature.
Yeah, we ordered it just in case there's some weird catastrophe, or somebody forgets, or there's turnover or whatever, and no one's available to heat this or
Right.
to fire it, and then for some other reason, the lodge boiler is down. It's there as like a ultimate backup to prevent this from turning into a 2,000-gallon chunk of ice.
And how do you confirm it's actually heating?
You'll hear it.
You'll hear it heating the water.
You'll hear it. Remember, an electric water heater. I don't know if you use
Okay,
electric
so
water
you'll
heater.
hear it. You'll hear that.
Like that, yeah.
And you'll be able to check the temperature on
You
the.
also can look at the meter and it's spinning off the wall.
Yeah.
Literally.
Yeah.
I tested it. It draws 35 kilowatts with both of these running.
Ouch.
35 kilowatts. Anybody know what you pay per kilowatt hour? 50, 40, 21, 50 cents? 50, that's easy to figure, 50 cents.
Well, then this cost equalization, so I think it's down like 35.
About 20 cents with PCE.
I can't do it in my head. That's big bucks.
Yeah, it's not worth it.
Yeah.
But just for
Okay.
reference, the other reason is because in some parts of the country where these get installed, electricity is really cheap, and they sell off-peak power. So that's why they sell them as a kit. We got it for you guys just as an ultimate backup to the backup.
So we covered position 0 disabled. Position 1 is what you want. That keeps it from freezing. Where does it start heating again?
35?
Beautiful. So 45 to 50. Position 0, 1. Position 2 heats to 170. And that's, again, this is the bottom of the differential scale. So at 170, it'll start heating up to 175, drop again. Position 3 is 190. You can hear the meter spinning off the wall.
Or you just need minimum.
Pardon me?
Just
Yeah.
the 45.
We're just worried about keeping it from freezing.
Right.
Anybody think of another scenario where you might have problems freezing?